Cyclical function models, the Singapore Flyer. Just a quick reminder, guys, that what you do today and tomorrow in the Edpuzzle videos with this packet, you're going to do a Canvas assignment on Wednesday and Thursday, so make sure you know what you're doing. If you need help, ask Mr. Fikes or see if somebody around you kind of gets what's going on, asking questions. All right. By the way, everything you're doing this week while I'm gone has to do with Ferris wheels. Yay, it's kind of fun, right? Sure. Okay, so we're looking at the Singapore Flyer, which, let's see here, opened in Singapore, obviously, in February 2008. So at the time of its opening, the giant Ferris wheel was the tallest in the world. The Singapore Flyer consists of an observation wheel with a diameter of 150 meters. That's important, okay? A diameter of 150 meters. Atop a boarding terminal, giving the structure an overall height of 165 meters. Okay, you should definitely stop right here and make a note that if the overall height was 165 meters and the diameter of the wheel was 150, okay, then that means that your boarding terminal must be how tall? 15 meters, okay? All right, let's keep going here. 28 air-conditioned capsules rotate on the outside of the wheel to provide unobstructed views of the city. The wheel rotates at a constant rate of 26 centimeters per second. This is slow enough that the wheel does not need to stop for loading and unloading unless there are special passenger needs. And remember, the like air little capsules are where people sit. They have these on the Texas Star at the State Fair, so you've probably been in one, although probably not air conditioned. All right, so it said to draw a diagram, and this kind of took me a little while, so I did not want you to have to watch me make this, which is why I'm just going to copy and paste. Okay, so here's my sketch, and you'll notice that my wheel is about 15 centimeters off the ground here. It's not centimeters, sorry, 15 meters off the ground. My height is all the way up to 165 in total. The center has to be 90. How do I know that? Okay, well, if the terminal is 15 meters tall, the diameter of the wheel is 150, then you should be able to figure out the radius on this thing is 75 meters, which means 15 plus 75 puts me right at 90. So 90 is the center of this wheel. Again, that's an important calculation that you be able to make, is where is the center of the wheel, or how high is the center of the wheel from the ground. Let's keep going. Based on the information given about how many minutes would it take for the Singapore Flyer to make one full revolution? Hint, start by finding the circumference. Let's just go ahead and do that. The circumference of this wheel is 2 pi r, and again, we know that r, we just talked about it, is 75. And I can just type this into my calculator. All right, so 2 pi r looks like this, second, caret key, 75. So my circumference is 471.24. All right, so we got the circumference. Now what we got to do is we got to figure out how long it takes the wheel in minutes to start from the bottom and go all the way around again, right? One full revolution. The key piece of information is that it travels at a constant rate of 26 centimeters per second. All right, 26 centimeters per second. So what we have to do is we have to convert some things. Well, first of all, our answer that we just got is in meters. And we were given centimeters, 26 centimeters per second. So let's change meters to centimeters. And all we got to do for that is multiply by 100, which you probably know. But this is what this looks like. Remember, when we're doing unit conversion, the whole idea is you want to be able to cancel off units. Like I want to be able to do that. I want to be able to cancel off meters. So I got to figure out how to do that. Well, if meters on the bottom, 1 meter has 100 centimeters, which is perfect, right? It leaves me with the 1 unit that I wanted. So all I got to do is multiply 471.24 by 100. I think we all know that is just 47124.0, or just 47124. And so now I have centimeters. Okay, so we're going to go ahead and use this to calculate the next part. What we can say is that 47124 centimeters is in 1 rotation. And so what I want is minutes. I want how many minutes is this going to take? So let's think about what we can do. Well, and here's the key. They told us how many centimeters per second, right? And I want centimeters on the bottom, so it cancels with the centimeter units over there. So they said 26 centimeters in 1 second. But now I can cross off centimeters, so I'm happy. And then we keep going. All right, I want to be able to cross off seconds, so it's going to go on the bottom of my next ratio. And keep in mind what you want. You want minutes. Well, I can say 60 seconds is in 1 minute. And I think that's all I needed, right? My seconds are crossing out, so now I'm left with minutes per rotation, which is perfect, right? That's what I wanted. Now remember, in fractions, you multiply straight across the top, which is going to give me 47,124 over 26 times 60, which, let's do in our calculator here. So 47,124 divided by the way, if you don't use parentheses right now, you're going to get it wrong because your calculator is going to do order of operations. All right, times 60. Again, make sure those parentheses are there. And we get 30.207. I'm just going to say about 30 minutes. So about 30 minutes per rotation. And we're going to use this calculation here in a minute. Okay, flip it over. These next two questions are probably the most difficult in the entire packet, so let's make sure that we're listening, okay? All right, what is the height of a capsule 1 minute after it leaves a loading platform? And it's talking about what is the height from the ground? You may have to recall some geometry skills to help you here, and you definitely will. Taylor should be the best at this. I had Taylor for geometry. Okay, let's keep going. Make sure your calculator is in degrees, all right? That's super important. So first things first, I'm going to go to my mode, and I am going to click on degrees to make sure that I don't get some crazy number here for my answer. All right, so the height of a capsule. Y'all, this requires two separate calculations, and we definitely have to understand both. If we want to know how far it is off the ground, we have to know how much did it travel. And remember, it's traveling in a circle. Okay, well, if it's traveling in a circle is 360 degrees. And it's going to take us about 30 minutes to make that whole circle. So 360 degrees divided by 30, again, you can probably do this math in your head, is going to give us 12. All right, so 12 degrees per minute. That's what that means. So my wheel is traveling in about 12 degrees per minute, so that in 30 minutes it goes the whole 360. All right, 12 degrees per minute. And remember, I only want 1 minute, so that's what I'm going to use for this problem. Now I'm going to draw a picture to help me with this math that's coming up. And you guys definitely should be drawing pictures. Also, don't judge my picture because it's going to suck. All right, here we go. Here's my circle. Here's the center of my Ferris wheel. So we got to start labeling some things here. The first thing we're going to say is we know that the loading platform is 15 meters off the ground. And we want to know, where is this little capsule after 1 minute? Well, we just figured out that the degrees it had turned is 12, right? 12 degrees. And we also know that that's a 75-meter radius. So all of this we should already know. You're just seeing it in the picture here. Something else to think about is, remember how we talked about how the center of the wheel was 90 meters off the ground? Well, yeah, because this is a radius too, and it's 75. And 75 plus 15 means that from the center to the ground, I've got 90 meters. All right, and I'm going to erase these couple of words, a couple of these things. I'm going to try anyway. All right, I'm going to leave that one. So we've got our picture right here that we have to work with. Now, you guys, we have to use some sine, cosine, tangent functions. We have to use some trig functions here, and it's been a while, so please listen. All right, I'm going to go ahead and I'm going to make a right triangle. I'm going to draw a line. I'm going to draw a line right here at the bottom. And this might look like it's exactly 15, but that's just because my drawing sucks, right? It's supposed to be a little higher, although not much higher than 15. So what we got to do is we got to figure out what is this length right here. Again, it's not 15. Okay, well, we know right triangles. We know sine, cosine, and tangent, or if we don't, we're going to get some practice right now. So let's take a quick look. I have the hypotenuse, and I have this angle right here. What I want to do is I want to go ahead and I'm going to find this distance. And the reason I'm going to find this distance is because I can do 90 minus this distance, and that will give me this length right here. All right, think about it. If that's 90, then that is also 90, and I'm only looking for this piece of it. So once I find this distance x, I can go ahead and I can subtract to figure out the height from the ground. Here we go. We're going to use cosine. Why cosine? Well, because we have the hypotenuse, right, which is on the bottom. Cosine uses the hypotenuse, right? We know that's 75. And then here's my angle. My angle is 12. I'm using this side. This side is touching the angle I'm using. That's the adjacent side. So cosine uses adjacent side. Sine would have used this side, which we don't want right now. So cosine is adjacent, sine is opposite. So cosine. Let's go ahead and fill these numbers in. Cosine. All right, sorry, the video stopped recording, so I had to kind of merge a couple videos here. So we're going to keep going. So the cosine of x is equal to the adjacent over the hypotenuse. In this case, the cosine we're looking at is, or sorry, the degree we're looking at is the 12 degrees. All right, so we're going to say cosine of 12 degrees is equal to the adjacent side. Remember, that's the side I don't know, so I'm calling that x over the hypotenuse, which is 75. Now to solve this, we just got to use some algebra skills here. Let's get rid of the 75 using multiplication, but we have to do the same thing on the left side of the equation. So I just got to figure out what is 75 times cosine of 12, because that is going to give me x. That's going to give me the missing side. So 75 times cosine of 12 should give you, if you're in degrees, 73.4. All right, and that is x. Now I'm going to try and demonstrate what's really happening here. Remember, the entire length from the center to the ground is 90. We just figured out that from about here up is 73.4. And what we wanted was the height from the ground, and that's this little piece right here. So this is what you need to find. All right, the height from the ground is this piece right here. So we're just going to take the height from the center, which was 90, and we're going to subtract 73.4. Okay, and this is going to give us 16.6. So 16.6 is the height after 1 minute. All right. All right, I'm going to go ahead and erase this stuff because this was what I explained in the video a minute ago. Should have done this before we started. It's like the third time I made this video. You guys keep screwing it up. All right, let's keep on going. So what I'm going to have you guys do in Edpuzzle is I want you guys to try and figure out the 4 minutes. But I'm going to help you out a little bit, and I'm going to go ahead and I'm going to give you a drawing. All right, so let's see what this would look like. If we travel at 12 degrees per minute for 4 minutes, that's going to be 12 times 4 is going to be 48 degrees for our circle. So when we draw our circle, we're going to go 15 from the center to the ground, we know is 90. And this time our angle is about 46 degrees. So this time we've got about half of that quadrant right there. All right, so draw your right triangle. Draw your right triangle. Better than I am, hopefully. And we are trying to find this little piece right here, right? This little piece right here. Remember, from here to the ground is 90. So 90 minus x will give us this height. Right? Remember, this height right here is the same as this height. So we're trying to find 90 minus x to give us our height. You're still going to use cosine, and you're going to follow the same steps as we did in the previous example. All right, hopefully in the video you got 39. Is it 39 or 38? Now I can't remember. Hang on. Okay, you should have gotten 39.82. 39.82 meters. And now we're going to look at one more type of thing that could happen to you. So I'm going to do 8 minutes. All right, and I'm going to do it over here to the right. You're going to do another one just like this, so pay attention. All right, 12 degrees per minute for 8 minutes means that I've got a 96-degree angle this time. So here's my Ferris wheel. Here's the center. From here to the ground is 90, just like it has been for every other problem. All right. And we're going to go ahead and we're going to look at a 96-degree angle. So from the turning point, we're going to have to go about this far. That's about a 96-degree angle, and I'm just kind of ballparking this right now. Well, I can't draw a right triangle from that point if I do it like I did in the last two examples. So here's what I'm going to do. I'm going to go ahead and I'm going to draw my right triangle like this. All right, I'm going to draw my right triangle like this. I know this was 90, and so if I traveled a total of 96 degrees, then that means that this angle right here is just 6, right? The 90 is this square, and 6 is what's above that. This is a radius, and so I know it's 75, and now I want this piece right here, this x, right? Because from here to the ground is 90, so 90 plus x should give me my height off the ground for my capsule at this point. But it means I'm not using cosine, because from this angle, the x is now the opposite side of my triangle, so that's sine. So I'm going to say sine of 75, nope, sorry, sine of 6 degrees should be opposite, which is x, over the hypotenuse, which is 75. We're going to solve it the same way, multiplying by 75, and I get 75 times sine of 6 degrees, and I get 7.8 for x. So if I add 7.8 this time, I get 97.8 meters. So you guys have to be able to use sine or cosine, and you have to decide whether or not to add or subtract. All right, and that's going to give us for 8 minutes, we're at 97.8 meters from the ground. You guys go ahead and do 12 minutes in Edpuzzle, and it's going to use this same method over here. Okay, hopefully you got the answer correct. Your answer for 12 minutes should have been 150.68. 60, and I'm going to give you the rest, all right? 163.36. 20 minutes was 127.5. 24 minutes was at 66.82. 28 minutes is 21.48. And 30 minutes is back at 15 meters. Hopefully that makes sense, because at 30 minutes you're back where you started from, right above the boarding terminal. If you guys are totally lost, I just want you to take a deep breath, because I'm about to give you a formula for this. But this math that we just did is why the formula works. All right, so if you did miss the 2 questions in the Edpuzzle video, it's not making any sense. I'm about to give you a formula. It will get better. All right. Cross off this line here in problem 5. This is a typo. And we're going to make a quick graph here for time versus height. All right, time versus height. Now my height goes all the way up to 165, so I'm going to say that's 100, so that's 50, let's say that's 150, and we'll say this is 200. 30 minutes total, so 15, 30, and that will be my scale. So I'm just going to plot these points that I found above. So 1 and then 16.6 might be like here. 4 minutes at 39.82. Right, this is 5 minutes, so 4 minutes is probably like here. 8 minutes at 97.8 might look something like this. 12 at 150.68, probably right there. 16 is 163.36, and that's probably the highest that we're going to get, right? Because the maximum height of this thing was 165. 20 minutes is 127.5. Let's see, 15, 20, 127.5. Let's see, 24 minutes was at 66.82. 28 minutes was at 21.48. And then 30 was back down here about 15. So you guys can see that we kind of have a wave here. And if you will recall from pre-cal, if you took pre-cal, this is actually a cosine wave. And it kind of just maps it, right? First we kind of grow slowly off the ground, but then once we're like on this edge of it, we're growing a lot faster, and then we kind of go slower at the top and come back down. So try and explain, just kind of type me a few sentences about why the points fell the way they did. And I kind of said it already, so just kind of in your own words paraphrase. Y'all, that's all we got for today. All right, go ahead and finish your Edpuzzle video, and if you don't understand something, now's the time to ask your neighbor.